Hi everyone, this is going to be the demo of our latest production in predictive analytics. So let's get into it, and it's really the core of the computation, right? Then as opposed to integration with the rest of what we've been doing. Then I put the LSTM implementation on pause for now because some issue, and decided to go with something good, still very good, but a bit more manageable, which is Holt-Winters. And in its implementation as a triple exponential smoothing version with multiplicative seasonality. So let's first have a look at what this is about. So in Wikipedia, this is where it explained. Exponential smoothing is here. It's basically the idea that the more you go back in time, the less influence it has on the prediction, right? And on this in an exponential way. So there are different versions, but the best one probably seems to be the triple exponential smoothing, which is explained here. Then this is for the theoretical basis, and this is explained, and this is implemented in Python. Just a recall of the benefit of predictive analytics, we're gonna call PA from here on. Predictive analytics, generation of prediction, require it instead of anomaly detection first. But both require heavy computation, right? And the difference between traditional anomaly detection and predictive analytics, it's the predictive analytics generation can be done ahead of time as compared to the event we want to evaluate. The prediction being done ahead of time, it's available at the time of the event in real time, therefore, and we just kind of have to check the prediction versus the actual. Then in real time, the process is much lighter. So let's go with the demo and just some prerequisites. I'm going to show you the time series I use. I'm going to present you the program I've been using, and it's based on this guy code. But I use a different time series. So we're going to run the program, and okay, so let's go for the time series. This is the time series I will be using, and for which I'm going to compute a prediction. I don't really recall where I got this time series, okay, but just the format of the index into Elasticsearch is this one. Okay, so in order for you to reproduce my program and run it, you're gonna have to have an index with that format. The code I've been using for this program is the code of this guy. Okay, so I thank very much. And you're gonna retrieve everything in my program. So the difference, it's I'm not using the same time series. Especially his time series is a monthly one. Mine is a daily one, which requires a little change in the code. And as you've seen, I don't take the series from a CSV file, but from Elasticsearch. but and here it presents all kind of version of Holt-Winters: simple, double, additive, triple, additive, multiplicative. Then I took only the triple one and multiplicative. Okay, then after clearing my previous run, here is the implementation, right? The code. So it's made of two programs, those two ones. Okay, so the main. So let's have a look. So basically, this is a module, a Python module called from here. It's object oriented, and there is actually one class into the module, and we're gonna have to instantiate it. Then if we look at main, it's very simple. Then we import this module, right, and we instantiate the object with this parameter here, which is this file. So I'm going to show you no. Yeah, so it's for the connection to Elasticsearch. And if you implement this stuff, you just have to replace those stuff here. Okay. Here I'm gonna just move those two files, because the actual one with the password is this one here. Now let's look at the code itself. So it's here. So here, but you can't see. You can turn on Python debug if you want. You just uncomment this stuff. Otherwise, those are the modules I import, and even though I don't need a single, but for double and triple smoothing, I need this one, and I use this one. And we gonna compute the mean squared error that is going to give us the range of validity. Okay, so the rest is and everything here is object oriented, and there are different modules. So to get an idea of how it works, and it's this one, right, which is called in the main, and those are the different steps, right? So the code itself has a remove, single, and double, but you can use them, right? And this is what you get. Okay, so now I just have to run the program. For that, first I need to activate the virtual environment for Python, and then just Python 3. No, it's a main here I need to call to run, because and here we are, and this is done. Then the prediction is this one, okay, which is because the time series stops at 2022-04-8, the 8th of April. Then the prediction is computed for the next day, right? And it has this value, right? And the mean squared error is this one, and we should take the root square of it to get a range, right? So now let's look at how it looks on Kibana, because what this program does, it takes the series, there is a fit of the series, right? So, which is so the model tries to to be as close as possible to the series, and then compute a prediction, right? So this is what, and we're gonna see that on Kibana. Now here the result. Then it's the same time series, right? But this time here, these are the fit and the predictions. And we can see that, let's take one here. Here, this at that stage, at that time, okay, then the average, I mean, the quantity was 47, okay, and the prediction, the fit, right? So the model built here computed 492, so slightly above, right? So here we can take another one. You see, it's the actual is 680, but the model fitted as 676, right? So we can take another one. So each time, so it gives us a series of, based on the actual quantities, what a model built on Holt-Winters can do by trying to mimic this series. And when it mimics this series, this is what it finds. Okay, so sometimes it's a bit above, sometimes it's a bit under, right? And we compute. There is a way to compute these those errors, right? And get a sense of how much it's how good the system is. We're going to use these error computation for the prediction, because the prediction is just one number, right? But we need a range under and above. So, also, you can see also that we have one prediction added to the series, because the series has 98 items, and here we've got 99. So let's look at this one. This is a prediction, and you can see it's a prediction because as compared to this, there is no actual quantity, right? And we can see it looks a little bit plausible, right? Because here it was it keeps growing, and it's what Holt-Winters found, right? So now let's look at what the next steps for this module of the open source project Context 22 we're going to be working on. And currently we've got that, right? We've got a daily TS in Elasticsearch. We run it to this program, right, and this algorithm, and it gives us a prediction. So, right. So we need to integrate that into the whole Context 22 process, and it's going to be probably looking something like that. Okay, so we get the daily TS and in Elasticsearch, generates the prediction, but the prediction is then fed into the Enriched full SQL ETL, right? We use, and at that time, and this is the next step in this project, it's really to implement some prediction, some checks on prediction versus actual. We're gonna also add the check on the SQL injection by fuzzy logic. So really we're gonna add a series of checks when we do the enrichment of the full SQL ETL, right? So the full SQL ETL comes from the Guardian full SQL data mart, right? And from this program, it's going to generate two things: alerts on when the actual differs a lot from the prediction, right? So it's going to be, and we're going to feed these. Still feed the enriched full SQL here, Then exactly how we're going to do those checks, it's still being designed, but this is what we're going to do next. Then we've got some issues. Yeah, I didn't show you that, but basically you see that the date here is 8th of April, whereas the computation, right, gave us the 9th. Well, this is due to the time zone management in Elasticsearch. Then in Elasticsearch, whatever date you put in is UTC. Then the April 9th, it was UTC, and since it's just a date, it's a midnight, and it's a 9th of April 000. So 9th of April 00 midnight UTC is actually still the 8th for me here in Chicago, right? So I need to fix this issue as well. It's no big deal, but it's then. However, there is a big concern, which is and big issue, which is at what time we generate those predictions. Because here it was quite simple, right? It's but when you've got a lot to do and with much longer series, what do you do, right? And let's see what the issue is. So let's see, consider 4 weeks, right? And with each day of the week, right? So in time. So this is when are you going to compute the prediction for what day? So if you want to compute the prediction for that Monday, right, you're gonna have to get all these series. So meaning that you're gonna need, you cannot do the computation until Sunday has passed, right? So the computation for Monday, for the prediction on Monday, cannot be done before Monday. It has to be done on Monday, which is basically too late, because you need the prediction before Monday. Because let's say it takes half a day in your system to compute the prediction for Monday on Monday. So you are missing half a day already. So this is not really a good solution, right? So what we want to do is the following, right? So this is no good, right? So performing the prediction here at Monday midnight, it's for Monday, it's no good. So what we're going to do is split the series into 7 series per day of the week. So 1 series for Monday, 1 series for Tuesday, 1 series for Wednesday, and so forth. And we compute, which gives us 6 days to compute the prediction for the following Monday, following day of the week, right? So we go really from 0 minute, absolutely no time to compute the prediction, to basically we've got 6 days. But it means that the split of the series into 7 series per day of the week makes sense. And the answer, anyway, to me is yes, because in database activity monitoring, it makes sense. Okay. So first we established by experience, and I documented that into an article on LinkedIn you can refer to. Okay, so time unit for DAM is the day, right? Not the hour, right? And each day of the week, in general, is for specific task, right? The application does a specific task on Monday, a different task on Tuesday, blah, blah, blah. Meaning that the traffic on that day doesn't really depend of the traffic of the day before. It depends more of the traffic the week before. So, and this is what we are using to justify and implement this thing. And this is what we're going to do next, right? So take 1 series, split it in 7 series per day, and we compute for each series. So now we are looking for collaboration. So we are looking for companies that may be interested in working with us on these as an open source project, right? So basically our proposal is as the following, as follows. So we start small, like a POC. We are not going to and we're going to focus and we want to focus on extraction of sensitive data, right? Then we select one reasonable piece of traffic, for example, on server, on database, or a specific user. We decide on the Elasticsearch environment, on-prem versus in the cloud. We install CT22 Enriched ETL and these prediction module. Potentially, we can do also the SQL injection. We enrich the extraction of sensitive data within the selected traffic. So for a specific server, we extract and we enrich specifically the extraction, which are the selects on sensitive table, right, collections or indexes, and commands, right? And we analyze those different extraction. This is EDA stuff, exploratory data analysis, right? So I'm going to add it actually EDA, which is exploratory data analysis, which and we're going to select one or two SQL we want to follow, right? We're going to generate the prediction for them, right? And they will be available to check for checking in real time against the actual, either manually or by program. And we're going to do a post-mortem. So if you are interested in such collaboration on an open source project basis, right? Then please contact us, and here the different places, and also you can contact me on LinkedIn. So thank you very much and have a good day.